السلام عليكم. محاضرتنا الآن تبدأ من تعريف ماخ نمبر. ماخ number, which is denoted M, is defined as the ratio of the actual velocity to the sonic velocity. M equal V by C. M is greater than 1, the flow is supersonic. M less than 1, the flow is subsonic. M equal 1, the flow is sonic. Example 1. Air enters a diffuser with a speed of 200 meters per second. Determine A, the speed of the sound, and B, the Mach number at the diffuser inlet when the air temperature is 30 degrees centigrade. Solution. At the inlet of the diffuser, V equal 2000 meters per second, T equal 330 centigrade or 303 Kelvin. Analysis. A. Velocity of sound in the air at 303 Kelvin, where R equal to 287 joule per kilogram dot Kelvin, or K, and K equal 1.4. Then C equal under the root KRT, and it equal 1.4 into 287 into 303, and it's equal 349 meter per second. B. Mach number. M equal V by C. 200 the velocity by 349 the velocity of sound. It equal 0.573. Other example. Nitrogen gas at temperature of 350 Kelvin is a flow in a wind tunnel at a velocity of 500 meters per second. Find the Mach number and the type of the flow. Mean sonic, supersonic, or subsonic, depending on the value of Mach number. For nitrogen, R 296.8 joule per kilogram dot Kelvin, and K equal 1.4, T equal 350 Kelvin, V 500 meters per second. Analysis. C equal under the root KRT, it's equal 1.4 into 296.8 into 350, and it's equal 381.355 meters per second. M equal V by C. 500 by 381 equal 1.31. It is supersonic flow because M akbar more than 1 or greater than 1. Stagnation properties. The stagnation properties of the gas or the fluid flow in a duct to be defined and determined. Consider a flow in the duct as shown in figure 2. But this the duct, there is at the beginning or at some start there is V1, T1, ρ1, and V1. On the other start there is P2, T2, ρ2, and V2. By applying the first law of thermodynamics between these two starts, we can get that when Q and W, tau W and delta B equals 0, the duct is adiabatic, there is no work done and neglecting the change in potential energy. That Q equal W equal delta B equal 0. The energy equation becomes delta H plus delta KE equal 0, or H2 minus H1 plus half of V2 square minus V1 square, or H1 plus half V1 square equal H2 plus half V2 square, and it's equal constant. It means that the total energy of the system is constant. It will be as enthalpy only if the velocity equal to 0. This means that the energy that accomplished with the fluid is still constant. It will be as enthalpy only if the velocity becomes zero. The enthalpy can be noted as HO, stagnation enthalpy, the state at which the velocity becomes zero and the enthalpy P maximum is called the stagnation state. The stagnation at the stagnation state, velocity equals zero and h equal h naught, which is equal h1 plus half h1 square or h2 plus half v2 square. And this relation can be rewrite for any state as h naught equal h plus half v2 square or h naught minus h equal half v square. For ideal gas, h equals cbt and cb into t naught minus t equal half v square. The property with any subscript denote static properties. It means that T, B, rho it's static, but T naught, rho naught, and B naught it's stagnation state properties. T naught by T equal 1 minus V square by 2 CBT, where CB equal KR by K minus 1 and C square equal KRT as defined before. Then T naught by T equal 1 minus V square into K minus 1 by 2 KRT, and it equal 1 plus K minus 1 by 2 into V square by C square, or T naught by T equal 1 minus K minus 1 by 2 M square. As we know, the process is adiabatic, so B naught by B equal T naught by T is to power K by K minus 1, so it becomes 1 plus K minus 1 by 2 M square is K minus K by 2, and rho to naught by rho is also equal T naught by T to power 1 by K minus 1. Example: while driving in your new sport car at 150 km per hour in a still air at 27 degrees, you put your hand out of window with it toward to the front of the car. What is the air temperature on the center of your palm? The center of your palm, the center of your hand. Solution: the speed of the car V 150 km per hour and the air temperature is T equal to 7 degrees centigrade. It's want to determine the temperature at center of your palm when it is in the front of air. It is the stagnation temperature of air, T naught. Then temperature at your hand center is T naught, because at this point the velocity of the air is zero. Analysis: at the beginning we convert the velocity from kilometer per hour to meter per second, and this can be done by multiplying by 1000 and dividing by 3600, and it will be 41.667. From the equation of energy, H naught equal H plus V square by 2, or CBT naught equal CBT plus V square by 2, or T naught equal T plus V square by 2 CB, or T naught equal 300 plus 41.667 square by 2 into 1005, and it's equal to 300.86 Kelvin or 27.860, or can be solved by using T naught by T equal 1 plus V squared by 2CB, and it will be give the same result. Another example, an aircraft is flying at cruising speed of 250 meter per second at an altitude of 5,000 meters, where the atmospheric pressure is 55 kilopascal and the ambient air temperature is 256.7 Kelvin. The ambient air is first decreased and the diffuser before it enters the compressor, figure 3. Approximating both the diffuser and the compressor to be isentropic, determine A, the stagnation pressure at the compressor inlet, and B, the required compressor work per unit mass if the stagnation pressure ratio of the compressor is 8. From this figure, at the inlet of the diffuser, there is T1 and B1 and V1. At the end of the diffuser, V equals 0 because the velocity is declared in the diffuser to be 0 before entering the compressor. Solution: V1 equal to 250 meter per second, Z 5,000 meter, B1 55 kilopascal, T1 256.7 Kelvin, and BO2 by BO1 equal 8. The required are the stagnation pressure at BO1, B the work required in the compressor. TO1 equal T1 plus V squared by 2CB. Take CB equal 1005 joule per kilogram Kelvin. Then TO1 equal 256.7 plus 250 squared by 2 into 1005 and equal to 87.8 Kelvin. BO1 by B1 equal TO1 by T power to K by K minus 1, and it gives that BO1 equal 82.07 kilopascal. Now we can find TO2 stagnation temperature at the compressor outlet. TO2 by TO1 equal BO2 by BO1, and from this we can get TO2 equal 521.33 Kelvin. By disregarding potential energy change and heat transfer, the compressor work per unit mass of air is determined from equation of energy. W equals CB TO2 minus TO1, 1.005 into 521 minus 332. 0.332 minus 287.8 equal 234.7 kilojoule. Thank you.